Hello everyone. Let's solve this algebraic fraction together. And the first thing we must see as usual is a solution. And if you look at the expression very carefully, you have p squared and we are having 4. There is a way we can write 4 to have square also. It means 2 times 2, which is equal to 2 raised to power 2. So I'm going to replace 4 with 2 raised to power 2. And that of 1, if we have 1 raised to power 2, is the same thing as 1. 1 raised to power 2. 1 raised to power any number is the same thing as 1. So if we can do this replacement, then we can bring in the concept of the difference of two squares since we're having negative bits between them. And now this becomes 1 squared minus 2 raised to power 2 p squared. You see that? Is equals to 6p minus 3. Yeah. And this becomes 1 squared minus 2p all squared all over 6p minus 3. Why did I do this? I did this because if we have a raised to power 2 times b raised to power 2 is the same thing as a times b all raised to power 2. So we are fine. So we're going to continue from there, and it becomes 1 squared minus 2p squared all over the denominator. What is common? We have 3 that is common. 2p minus 3 divided by 3, that will be 1. So the denominator becomes 3 into 2p minus 1. And the difference of two squares is if a raised to power 2 minus b raised to power 2, this should be having an identity of a plus b times a minus b. So the numerator that we have to be 1 squared minus 2p squared therefore ends up to be 1 minus 2p times 1 plus 2p. So we're going to bring this in the place of the numerator and then retain the denominator and see how it will eventually turn out. So this becomes 1 minus 2p into 1 plus 2p all over 3 into 2p minus 1. You see? So you'll be tempted to cancel out here, but be very careful because here we're having 1 minus 2p. The 1 is positive, 2p is negative. But the denominator here, 1 is negative, 2p is positive. So it's not the same. So there's something you can do. You can manipulate the denominator so that you can have it at the same as this term in the bracket so that you can confidently cancel out. So what do I mean? We're going to multiply the denominator by minus 1. So if we do that, the expression becomes 1 minus 2p, 1 plus 2p all over 3 into minus 2p plus 1. You see, this is what I'm saying. And if you want to rearrange it to be 1 minus 2p into 1 plus 2p all over 3, the positive ones there first, 1 minus 2p. You see that? So here, this can cancel out. What is left? We are left with 1 plus 2p all over 3. Yeah, this is our final answer. But somebody will argue that how come you multiply the denominator with minus 1, but the sign of the 3 remains positive? Yes, it has to remain positive because the bracket inside has been affected by the negative. What do I mean? Look at where we factor it from. It was 6p minus 3. If we work on this, what is it? 6p minus 3. Yeah, so let's multiply this one by minus 1 and see how it goes. If you multiply here by minus 1, it will be minus 6p plus 3. Isn't it? Yeah, that's correct. So if you bring out 3 that is common, it will be minus 2p. And 3 divided by 3, this is 1. Eventually, this is what we got here. You see, it's the same thing, even though the sign of the 3 remains the same. So if we do this, we are very correct. So be careful when you multiply through by a negative sign, so that you don't run into trouble of messing it up. Thank you for staying tuned. So if you are meeting our channel for the first time, please do well to subscribe. Hit on the notification button so that you'll be the first to know anytime we post a new video. So if you have not liked this video, please like it before you go. Thank you for staying tuned. Bye-bye.